All right, we're back with example 2. So we're going to be completing a 2-column proof. We're going to fill in the blanks to complete the 2-column proof. So we're given this figure here, xy. This is what we're given. This is our starting point, xy. And what we have to prove is the line segment xy is congruent to the line segment xy. So we have to prove that. Now this seems very, what's the word, obvious. However, I'm going to show you how this works. So this first part, the reason why we can write that is because that is the given information. We have a line segment XY. It's given. Now, we are going to state on number 2 that XY is equal to XY. Now, why can we say that? Why can we say that XY is equal to XY? Well, we can say that because of the, do you remember what it's called? The reflexive property of equality, right? Now, we need to get to this. Now, this has a congruent symbol. This has an equal sign. So we can switch that. We can go xy equals xy and move it to the line segment xy is congruent to line segment xy because of the definition of congruent segments. And this is going to be one that you're going to need to put on a flashcard, okay? And the definition of congruent segments. Remember, definition is a biconditional statement, which means the converse and the conditional are true. So it would basically say, if xy equals xy, then line segment xy is congruent to line segment xy. Or you could do the converse. If line segment xy is congruent to line segment xy, then xy is equal to xy. So both of those are true. So it looks like this. xy is equal to xy, and also line segment. You can go back and forth between these equal and congruent symbols because of the definition of congruent segments. So this is one you're going to use a lot. So go ahead and put it on a flashcard and memorize that definition of congruent segments, definition of congruent segments, okay? So that's how this proof works. But the takeaway from this is learning the tool of definition of congruent segments. All right, let's move on to the next one. Check it out, example 2. All right. So we are given that angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. What we need to prove is that angle 1 is congruent to angle 3. Okay, so that's our proof. Angle 1 is congruent to angle 3. So we have angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. And we need to prove that angle 1 and angle 3 are supplementary. No, just are congruent. Angle 1 and angle 3 are congruent. Okay, so to do this, first what we're going to do is we are going to, now let's just, before we get started, let's go ahead and just get some, whenever I like to start proofs, I like to try to just wrap my brain around what's going on by just using actual numbers. So that's just a strategy I use, because when we're using all these words, sometimes it's hard to figure out the direction I need to go. So basically it's saying angle 1 and angle 2 are supplementary. So I'm going to actually just put some values on this. So this is kind of big. It's supplementary. Supplementary, remember that's equal, 2 angles equal 180 degrees. So I'm just going to say that angle 1 is 150 degrees and 2 would have to be 30 degrees. All right. These are made up numbers. I'm just making it up to try to wrap my brain around what this is and the direction I need to go in order to prove this. So angle 1 and 2 are supplementary, and then it says 2 and 3 are supplementary. So if 2 is 30, then that would mean that 3 would have to be 150 if they're supplementary, right? And then you can see that they are the same. Angle 1 and angle 3 are the same, okay? So we can see that that's true, but we have to actually prove it and justify it and all that type of stuff. But at least I know that this is actually true, okay? So the first thing I like to do is go ahead and write down that given information. So angle 1 and angle 2 are supplementary. And angle 2 and angle 3 are supplementary. And that is given. Now, in one of the previous examples, there was something I talked about, and I was like, hey, whenever you see this, you have to remember that you can do something else, and it has to do with writing an equation. Do you guys remember what that was? It was the definition of supplementary angles, which state that whenever I have angle 1 and angle 2 are supplementary, I can rewrite that as an equation. I can say measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And then I can say the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. So I can do that because of the definition of supplementary angles, which is really key, that I can take this information and make it into equation, because once I can do that, then I have access to all of my algebraic knowledge that I have and that you guys have too. Supplementary angles. Okay, so what I see here is I see that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees, and I see the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. So what I see is that they are both equal to 180 degrees. They're equal to the same thing. So because of that, I can substitute this in for this, and or this in for here, and just set both of the equations equal to each other because of substitution. Okay, so this would be the substitution property of equality. So do you see that? Is that clear or is that confusing? So here we have the measure of angle 1 plus the measure of angle 2. That is equal to 180 degrees. And here is 180 degrees. And this is also equal to 180 degrees. So because this is equal to 180 degrees, instead of writing, I'm rewriting this again. Measure of angle 1 plus measure of angle 2, right? That's right there. But instead of writing 180 here, I'm substituting what it equals, which is right here, and I'm putting that in for 180 degrees. So that's going right there. Okay? All right. So then what I'm going to do is something a little strange. Sometimes they do it when we're doing proofs and they have just nothing but variables here. So what I'm going to say is I'm going to say the measure of angle 2 is equal to the measure of angle 2. Now why can I say that? I can say that because of the reflexive property of equality. But the reason why is I want to say that these two things are the same, because if they are the same, then what I can do is I can rewrite this, right? The measure of angle 1, I'm just rewriting this. If these two measure of angle 2 are the same, then what I can do is I can subtract the same thing from both sides, and what happens? These cancel out and these cancel out, right? And that is the subtraction property of equality. And what I'm left with is the measure of angle 1 is equal to the measure of angle 3. And that's through simplification. Now let's go up to what I'm supposed to prove. I'm supposed to prove that angle 1 is congruent to angle 3. And I have measure of angle 1 is equal to measure of angle 3. So I am super duper close, okay? And so what I'm going to say is I'm going to say angle 1 is congruent to angle 3 because of the definition of congruent angles. So just like we just talked about the definition of congruent segments, they have the definition of congruent angles, which basically means this right here. The measure of angle 1 is equal to measure of angle 3, or that is the same thing as angle 1 is congruent to angle 3 by the definition of congruent angles. Or if you ever have angle 1 is congruent to angle 3, you can change it to the measure of angle 1 equals the measure of angle 3 because of the reason definition of congruent angles. All right? So that's something else that needs to be a flashcard. You need to memorize that just like you memorize the definition of congruent segments. Okay, and it's just really just kind of like a formatting thing when you're dealing with proofs and you're going to equations and then you need to prove it and you need it to be a congruent symbol. So that's when you're going to use those types of things. It's just kind of like a format thing. So now what I want to do is I want to go over 2 theorems, all right, with you. The first one you're going to use a ton. And it is the linear pair theorem. And that says if 2 angles form a linear pair, then they are supplementary. Okay? So if A and B form a linear pair, so that would be something like this, right? Like you have a line and you have an angle, and this is angle A and this is angle B. All right, they form a linear pair, therefore you can say they're supplementary. And this is really, 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 really important. You're going to use this a lot, the linear pair theorem. And the reason why is because you're going to have a picture like this, right? And let me show you how it's going to work. Okay, so you're going to have a picture like this, and you're going to be like, oh, it's a straight line. That's a linear pair. So you're going to say angle A and angle B are supplementary, right? Because of the linear pair theorem. Okay? Now, after that is stated, okay, so this is going to be the first thing. You're going to see a picture, right? And you're going to be like, oh, A and B are supplementary because of the linear pair theorem. Then, the next thing that's going to happen is measure of angle A plus measure of angle B equals 180. Why? Because of the definition of supplementary angles, okay? So this right here, you are going to use this strategy. You're going to use this technique a lot. You're going to see a picture. You're going to be like, oh, they're supplementary angles. I can say that because of the linear pair theorem. And then you can be like, oh, because they're supplementary, I can say that they both equal. And then you can get to your equation, right, by the definition of supplementary angles. You can also go backwards. So let's say you did a whole bunch of equations and things like that, and then you ended up with something like this. Then if you have this, you can say that A and B are supplementary because of the linear pair theorem. Like if you had to prove that A and B are supplementary for some reason, you can go backwards. So this can go frontwards and then it can go backwards. So this progression of thought needs to be on a flashcard because this is going to help you maneuver through proofs, all right? Something like that. Okay, so that's just a technique, a strategy. You're going to use this a whole lot. It's not going anywhere. Okay, that's that. Now this other one that we're going to talk about, this one is not going to be as popular as this one, but this is going to be one that you have to know because it's going to make your life easier, and I'm about to show you why in just a second. So this is the congruent supplements theorem. The congruent supplements theorem. What the congruent supplements theorem says, okay, is if 2 angles are supplementary to the same angle. Okay, so if 2 angles are supplementary to the same angle, or to two congruent angles, then the two angles are congruent. So let's talk about this first bit right here. If two angles are supplementary to the same angle, then the two angles are congruent. So let's say we have supplementary, right? So let's say we have something like this where we have, I don't know, maybe this is, 130, and then this is angle A, and then this is 50. This is angle B. So if two angles are supplementary to the same angle, so A and B are supplementary, right? 130 plus 150 is 180. And then I'm going to have C here, and C is also going to be 130. And then B and C are also supplementary. So A is supplementary to B and C is supplementary to B. So if two angles are supplementary to the same angle, so the two angles that are supplementary to the same angle is A is supplementary to B and C is supplementary. So A and C are the two angles that are both supplementary to B. Okay, then what it says is then the two angles are congruent. So we can say that A and C are congruent. So this is just kind of saying angle 1 and angle 2 are supplementary. I probably should have just made this 1, 2, and 3. I'll make this 1. So basically this is 1, this is 2, and this is 3, okay? So 1 and 2 are supplementary, and 2 and 3 are supplementary. Therefore, 1 and 3 are congruent. Angle 1 and 3 are congruent by the congruent supplements theorem. Okay, now let me show you why these theorems are very, very nice sometimes. Okay, so this is a flashcard. Both of these are flashcards. So flashcard. You got a flashcard, both of these. Flashcard. Go through them. I hope you're going through your flashcards like routinely. Okay, it's really super important. Okay, so we're going to go back to this last example that we just did. All right, so we did all this work, right? We had angle 1 and 2 are supplementary, and angle 2 and angle 3 are supplementary. And then we did that. We used the definition of supplementary angles. We set them equal to each other. We did the reflexive property equality. Then we subtracted because we showed that they were both equal to each other, and therefore we could do that. Then we simplified in definition of congruent angles. Boom, we proved it. Okay? Now let's try to do this a second way. Okay, so we have given angle 1 and angle 2 are supplementary, all right, and angle 2 and angle 3 are supplementary. We need to prove this right here. Okay, so what I'm going to do is I'm going to write down the given information. Angle 1 and angle 2 are supplementary. And angle 2 and angle 3 are supplementary. So that is given, right? Well, we're trying to prove that angle 1 and angle 3 are congruent. So I would say since angle 1 is supplementary to angle 2 and 3 is also supplementary to angle 2, they're supplementary to the same angle. So therefore, angle 1 is congruent to angle 3, right? So if angle 1 and angle 2 are supplementary and angle 2 are supplementary, then angle 1 is congruent to angle 3 by the congruent supplements theorem. And that's it. That's the proof. So instead of doing this right here, all of this, we just kind of narrowed it down to right there. Because of the congruent supplements theorem. And really the reason why the congruent supplements theorem is a theorem is because of this proof we did earlier. Okay, that's the reason why we now have a direct proof, because we did prove it. We proved there. So yeah, so that's it. So make sure that you memorize your theorems and memorize this sequence of with the linear pair theorem. So linear pair theorem to the definition of supplementary angles. Memorize that order because you will use that in the future. All right, great job, and we will see you for the next example in just a little bit.